and then all the beautiful stuff will happen before I hit the record button, right? And that's always the way. It's like I realized that it's really tough to do a pre-interview with people, because if you get on well with them, you sort of start chatting and everything's relaxed and you start talking about all the things that you're going to talk about, and then you didn't recorded it. And then when you does come to sort of recording it, everyone's a little bit more guarded, I suppose, kind of thing. So anyway,
or you've lost something of the magic. That's actually, I recall when we first chatted, that was starting to happen, and cut it off. So now exactly. I'm fresh.
Right. Yeah. Now, and where are you at the moment?
I'm in our office in China.
Right.
I'm in Shenzhen.
So excuse my geographical ignorance of China. Whereabouts is that? Sort of on the clock kind of thing.
So Shenzhen is on the clock of China. It's around. Oh, somebody out there is going to be upset at me for not knowing, but I would say it's around 4 o'clock probably.
Oh, okay, right. So on the southeast coast, kind of.
Yeah, it's on the southeast coast. It's basically connected to Hong Kong. So
gotcha.
I fly into Hong Kong. It's a 1 hour drive from there.
Got ya. Got ya.
All the way to the office, it's 2 hours.
Got ya. Cool.
Yeah. So this week I'm here, and then next week or in 2 weeks I'll be in US, and then a week after that I should be at IBC.
Oh, you're coming to IBC for the
yes.
For the yeah. Oh, that'd be good fun. So I'm going to see you. Are you going to be on the Friday, the 12th? Yeah.
Yes, I will be. I have to triple check, but I'm pretty sure I will be.
Cool. Okay. So he's just got a social drink for the Starting Pixel social drink. So there's one at the IBC pub for an hour, I think it is as well. Cool.
Keep my eye out for that.
All right, let's get it going. We've got, as I said, we've probably got about 30-40 minutes as well.
Yeah.
So we'll do it. Stop. Okay. So welcome, fellow Pixel. I got it right this week as well. Coming from the glorious Dean Street Podcast Studio in sunny Soho in London town. So LED walls, they're these big things, and they're very synonymous with virtual production. A lot of people, when they hear, if they've heard of virtual production, when they hear the words virtual production, they immediately imagine this vast, big array of LED panels. Is incredibly impressive to see, to say the least, which is sort of not quite right, but also that's fine because it's really, really important as well. So today's guest, we connected, I think some time ago, but we've only chatted a couple of times. He is a color scientist for LED panels. Who knew there was such a thing? Of course there was such a thing. There's lots of scientists who go sort of and do stuff that nobody ever hears about, but it makes things work, right? So LED panels aren't cheap. They're sort of not designed for filmmaking either. There's a technology challenge with that as well, but they are delivering filmmaking as well, which is really, really sort of cool today as well. And so as I said, our guest today, Tucker, is a color scientist for a global supplier of LED panels as well. So my first question, Tucker, is tell us a little bit about the challenges of LED panels and filmmaking that you've observed from your sort of place in the world.
Yeah. And thank you for the introduction. There's many, many challenges when it comes to LED wall. I've tried to leave the entertainment industry a few times in my career and get sucked back because it is really interesting on my side when you get into the technology. And so for ROE, that's what I do. I look at new technology trends and where not so specific on each product, but what can I do across products or across our markets to improve image quality and for relevant to VP, deliver better in-camera performance, etc. And one thing that I think is the most challenging is spec-driven sales. And I mean, there's a place for it. It has to happen because there's a million options and everybody knows. So at some point, it's useful to have a spreadsheet to say, okay, these ones have 10 good things and 4 bad things. This one has 12 good things, 2 bad things. Boom, decision made. But the truth is, actually, every single thing in the design of an LED wall is a good thing and a bad thing. So the example I really love is about pixel pitch. So everybody thinks, okay, you have more pixels, the better. On one hand, I'm happy with that because the pixels are the part that everybody sees. That's the part everybody loves. So I'm all about that. But for example, if you take the same LED package that you use on a 2.8 LED tile, and you shrink it to a 2.6 or a 2.4 because you just want to increase resolution, you get a big, big reduction in contrast ratio. So you might lose 2 or 3 stops of tone reproduction. And there are no cinematographers that are satisfied with losing 3 stops of tone reproduction. So you think it's a good thing and a bad thing. The only thing that's kind of universally a bad thing is the scan ratio. If you have a really big scan ratio, that definitely is not leading you in a better direction. But that's something we have to settle with.
I tell you what we do. So one of the things about the Starting Pixel podcast is what we set out to do really is to try and demystify some of the technology for traditional departments, right? So art departments, cinematographers, directors, anyone, sound even, right? Mm-hmm. So, and all this technology, at the basis of as I like to explain it at the most dumbest terms, is like it's like a really big TV kind of thing, right? Now I know, don't bite me for that. So let's go back just a couple of steps actually. So you mentioned pixel pitch, and you mentioned, I think most of the traditional people would understand stops, but then you mentioned scans. So give us a quick, literally very, very snapshot difference between pixel pitch. What is pixel pitch and what is scans?
The big things that people need to know about LED walls that everyone always asks about. It's your easiest glossary that you need to learn. So pixel pitch, that's what to us, that's resolution. Because in terms of an image raster, 4K means nothing to me. I can build you a wall with 5,000 tile, 150 feet wide and 40 feet tall if you want. We've done it, and I'll do it again. No problem. So for us, like, okay, that kind of resolution doesn't make any difference. What we care about is how small are the pixels and how close are they together. So that's pixel pitch. That means that you have more texture, more detail in your image in your camera. And it also benefits something called Moiré. We'll talk about that later, I'm sure. So that's pixel pitch. You need to know pixel pitch. You need to know brightness. So if you come from a lighting world, you think about, someone says, this is 1,000 lumens projector or 1,000 lumen light or something. Well, LED walls, it's a little bit different. That's because of the geometry. So when you look directly at something, so a lighting person talks about lumens or lux, that's the amount of light that is coming towards you, what's falling on something. So that's the amount of light that's falling on my desk. When we talk about a screen, what we care about is when I look directly at the screen, how much light, basically in a straight line, is reaching from the screen to my eye. And we call that nits. That's the difference. And if you remember back to your physics class, so the cow on a hill rolls down the hill because cows are round, and there's no friction and everything is perfect. There's a very simple relationship between lux and nits. If the LED wall has no viewing angle shift, it's perfectly normal, then you can multiply, I'm going to get this wrong one way or another.
That's fine.
You can multiply the nits times pi, and that would give you the equivalent lux of a projector, of a light going on that surface.
Got you.
So,
right.
Yeah.
Still quite technical. So DOPs.
Still quite technical.
DOPs are loving that, but it's the brightness, right? So it's
the brightness.
So we care about, and of course, and correct me if I'm wrong. This is my rudimentary understanding of it. The closer the pixel pitch, so the closer those LEDs are together, the smaller they have to be. I am assuming.
Yep.
And that means actually what they're able to emit isn't going to be as bright as a bigger LED. Is that about right?
Yeah, that's right. So they get smaller. So as you shrink the pitch, the brightness goes down.
Right.
But you also have more LEDs. So It's not quite a total loss, but you lose light faster than you gain resolution.
Right. So there's a compromise of this. So
there's a compromise.
There's a compromise, and we were sort of talking about that sort of a bit earlier on. And then the other thing you said was about, brightness scanning. And then what was the next one? Brightness.
So the brightness, the next kind of glossary term people should learn, that I think is, if we just want to hit on the important parts, is scan ratio, or I'm going to put two terms together and I'm going to call it one term, scan ratio and refresh rate. So it's basically how many LEDs are in a group.
Right.
So the LED screens, the LEDs aren't on all the time. They're grouped together, and they don't all activate at the same time. And that can cause camera artifacts. People call them scan lines. Right. So one way to improve that is with improving what's called the scan ratio. So you group, instead of having, sorry, it keeps getting so technical, but you have a piece of electronics that turns on the LEDs, and that electronics goes from line 1 to line 2 to line 3. And if you have 8 lines per driver. We call that a scan ratio of 1:8. Drivers are the second most expensive part of the LED screen. So it's better price-wise to say, well, I don't want scan 8, maybe I do scan 12 or 24. And that's something you see all the time. It just means the pixel grouping, and it has a lot of trade-offs, but we'll get really in the weeds if we keep going on that.
So less is more expensive because you've got to have more drivers, right? Effectively. Got you.
This is more expensive and it's better quality.
But it's better quality. So again, there's that trade-off as well.
Yep.
Got you.
Yep.
So is it those 3 things? Any more?
I'll give you one more, because it'll lead us into talking about something that people do understand better, which is things like exposure, tone, blah, blah, blah. So that's a reflectance. So
yes,
we think an LED wall is black, but some LED walls are blacker than other LED walls, and they also have glossiness property. So very shortly, for all the people who love technical stuff, very shortly, perhaps even by Monday, we'll have a white paper on our website specifically about this topic. But basically, you can measure the amount of light. So if there's, I'm going to go back to a lighting term, if there's 20 lux falling on a LED wall, so that's 2-foot candles, that's not much light. How much percentage of that gets reflected back towards the camera? We can measure that, and that affects your tone reproduction. Just with these 4 pieces of knowledge, now we're armed to talk about how things are actually going to look in camera.
Right. Yeah, because so my experience of that was quite early. It was quite early on, and actually turning. What we used to do was turn the wall off, and then you can visually see how much reflectance there was, because you put the lights up and you can see there's quite a big hot spot. And of course, then you turn the LED wall and it's not as it's brighter, or there's a sort of anomaly there as well. So completely
it's not as vivid there or something.
Yeah, that kind of thing. Which again is this sort of compromise. You just need to make sure that that the shots, it's not in shot kind of thing. Cool. Okay, that explains LED panels. And just for the really people who don't know, an LED, what's the sort of size of an LED panel?
A single LED tile is around 0.5 meter by 0.5 meter,
right?
500 mil by 500 mil.
So you need 4.
Standard one.
So you need 4 per square meter.
Yep.
And they're sort of in the thousands of dollars per one mark, aren't they?
I think that there are some that you can buy for less than $1,000, but they are the worst of the worst ones.
Right.
So typical one is thousands of dollars.
Yeah, so thousands of dollars for each one. So you times that by 4 just for a square meter. And if you're sort of looking at a big wall, that's not a small amount of investment.
No, it's not a small investment. No, it's not a small investment.
Cool, especially.
And
that's cool. One thing I was going to ask you, actually. So I used to work in print, and you mentioned Moiré a little bit earlier on, actually. And in print, they also had always this thing about Moiré pens, because if the dots didn't line up for CMYK, so C, cyan, magenta, yellow, and black. K is black. So if they didn't line up properly, you get this Moiré pan. And then something was invented called stochastic points or lighting, which actually all of the rather than it being a dot of ink, it was a little like a what you wouldn't know what's it's, but I imagine
I won't know what's it's.
No, what's is a crisp in the UK. It's like this. It basically it's a little curved corn thing. Oh, I know, Cheeto. It's a bit like a Cheeto shape.
Okay.
Right. It's like a Cheeto. Just explaining this out, I think. And so basically these things are like, these are sort of, so it's a random pattern, and you'd never ever get these things. So, and this is, and I probably know the answer to this, but why is everything so rigid because that's that actually, maybe explain a little bit before we go into that, actually what the problem with Moiré is.
Yeah, so Moiré is something you can see, if you look for it, you can see it everywhere. So like in the printing industry, that was a big problem with halftone patterns. So if the pattern, so they print the dots, you can't print a cyan dot and a black dot right on the same part of the paper because they cover each other up, and then you don't get the effect of them blending. So you want to spread the dots out so that you get even coverage. If you try to do that in a regular way, you will discover that there is no possible way to print arbitrary images with this arrangement of dots so that the image data doesn't also align with those grids and cause some kind of ugly pattern. So there's some tricks they do in the printing industry. That's one, and I know a few others that they've come up with. But you can see Moiré if you drive down the highway. You see 2 chain link fences, or actually, my favorite way to see it is driving down the highway past. We have a lot of beautiful farms in California, and the way that they, like a row of corn, perfectly lines up, and then on the side it lines up differently, and then in between those two you get like this beautiful fan pattern. That's also Moiré.
Right.
Moiré is an optical phenomenon that at any time there is a regular grid, and then you look at it from any regular perspective, and there's an overlap between parts of the grid. So like in a cornfield, it's one grid, but because you look at it on the side, it has some depth. But if you drive past 2 chain link fences, you have one fence and you have another fence, and you get a pattern that even the 2 fences aren't related to each other. You can see some strange diamond shapes. If you print, you get a transparency slide and you print a random array of dots, and you put another transparency slide, a random array of dots, and you put them on top, you'll see circles, strangely.
Yeah.
If the dots are circular. That's a funny thing about Moiré. So on an LED set, if you have a regular grid of pixels and the camera also has a regular grid of pixels, one of those things needs to be really optically, in terms of the what's called the field of view, an order of magnitude smaller and bigger than the other. And we would prefer that the LED wall is much higher resolution in terms of angular resolution than the camera system. And the reason for that is then the camera system won't be able to resolve the grid at all, and it won't have any ugly patterns where what happens is that you get a red pixel that perfectly lines up with a red pixel on the LED wall will perfectly line up with a red pixel on the camera sensor. So that pixel will be really bright. But then the one next to it, the red pixel will perfectly line up with the blue of the camera sensor. And that alignment gives you this strange rainbow pattern where even though you might be showing flat white, some of the red pixels in some parts you can't see them. So then those are cyan, and then other parts the blue pixel's missing, so that's purple, and other parts it's the green that's missing, so then that's another color. That's what Moiré is. Is that ugly? Or I don't think it's ugly. A lot of people say it's in the way.
The thing is, it's in the way, right?
But
that's the thing. It's not what you want, right? It's like that's.
But another funny trick that I like to challenge people with is if you get the opportunity, I know many people will be at IDC, but if you get the opportunity to come and look at a really high resolution screen, like a 1.2 or 0, we'll have a 0.7 at IBC, look at it up close with your eyes and stare at the pixels, and you can actually get Moiré from an LED screen to the cones on your eye.
Oh, wow. Okay. That's quite cool.
The shape of the pattern that you get it'll be a star hexagon.
Got you. Interesting.
Yeah.
Interesting.
I love Moiré. I got one more.
Right? Yeah, but it's I can imagine.
Fascinating thing.
Go on, yeah. Go on, do it.
So I mentioned what shapes it are, right? So if you have your eyes in an LED wall, you'll see a star shape. If you have dots on a printer, on a printed overlay, you'll have circles. On a chain link fence, you have diamonds. Moiré, one way to think of it, or one thing that comes out of it, is that it is actually a magnifying glass. It magnifies some aspect of the pattern underneath. So if you print a bunch of tiny number ones on a piece of paper, and then you put a grid of tiny dots or also tiny ones on another piece of paper and overlay them, the pattern that you'll get will roughly be in the shape of a one.
Interesting. Isn't that cool?
So Moiré is a cool optical thing.
Yeah, and of course, which for someone like you is just like a brilliant challenge as well. It's like this is what I'm born to fix, right? Kind of thing.
Yeah, or born to fix or
cursed to understand. Yeah, I understand, right? It's physics, right? You can't. There's certain things that you just can't.
But there's no fixing it. But then it all comes about. Okay, what's good enough? What is the real scenarios that we can plan, and what are the cost limitations and advantages? That's why you see huge LED volumes opening in parts. Recent new LED volumes are still 2.2, despite the fact that we have 1.5. Potentially, I would be happy to. It'd be difficult when I could do a 1.2 LED volume with COB. So we could have higher resolution LED volumes, but there's a cost and a benefit. So at some point, the resolution is good enough, and it depends on the size of the volume and the plan and the exact scenario that you're in.
Well, I guess, and so okay, so So we've touched on a couple of things actually. So there's a couple of problems that we've flagged, and I think those are sort of quite well known. Then there's the reflectance that you've sort of touched upon as well in camera. The big thing is that we're all very keen on in filmmaking is color.
Yeah.
So and the color, and it's a complex color thing, right? When you're not. And this is this is sort of bit my understanding from the Rob Chandler experience. You've got processors, there's the output of Unreal Engine into processors, then there's wires involved, and then there's the gubbins on the back of the tile, then there's the LED wall, and then there's air, right? I guess. Then there's glass at the front of the camera, then there's a sensor. In that sort of how does that all work color wise? I guess through the lens of really what a DOP is after, I suppose, because they don't know, and they shouldn't really care, I guess. But what are those sort of challenges, I suppose?
I'm gonna try to start from. I'm gonna try to not talk about specific technology as much as possible. It'll get there, but I'm gonna start from another place.
All right.
If I have a wallet that has a nice color, I quite like this color. But if I wanted you to make if I wanted you to make a color, or I wanted you right now to tell me what color that was, you'd have to come up with some way to describe it. And you could say it was orange. You could say it was kind of dirty orange because it's been in my pocket and blah, 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 dropped it on the ground. But that's not very specific. So at some point in human history, there was a group of people that thought, well, you need a specific way to describe what a color is. And those became what were known as color order systems, giving you color science history.
Yeah, that's cool.
Actually, all of this does boil down into why LEDs work the way they work and what does it mean for an image to have color. So color order systems, the two that are the most famous, one is called NCS, one is called Munsell. And they give a numerical way, and people could learn them and actually it's possible for people to get very, very accurate with these systems, or very consistent. So Munsell said, okay, there's 5 hues. There's red, yellow, green, blue, and purple. And then so hue, you can give a number. This one is 2 red, 3 yellow. So that's mostly yellow and 2 steps towards red. If it's 5 yellow, then it has no red or green. He gave a circle, so you could give that gives you the hue. And then people could learn a number that describes the lightness of the color. And then you can also describe the saturation or the chroma of the color in the Munsell system. And it was very scientifically designed, and it was a really accurate and good way for people to communicate color. If you learn the system and I said, okay, this is 3 yellow, 5/10. That is a color that you could go and paint or get a crayon or get a pastel. So that is a numerical way to describe color. Now, it's pretty difficult to do that. The resolution is pretty bad. You only have 10 or 15 steps of chroma and 10 lightnesses. But people could learn how to do it. And then when film came around, they thought, okay, how can we, especially color film, I should say, how can we describe the results of this process? If we project light through the film, we get some color. How can we just get the results of this process, describe it numerically, and figure out how to improve color, improve chroma, improve the lightness, blah, blah, blah. And they turned to these color order systems. Film became print, film and printing went hand in hand, becomes digital. And we kind of are stuck on this way. We need some numerical way to descend what a color is supposed to be. So once it came down to TVs and to transmitting images there, and later RGB, it turns out that using red, green, and blue is a very convenient anchor point, because if you use those as anchor points, and I tell you it's supposed to be so much red or supposed to be so much green, that encompasses the most number of colors that you can describe with only 3 anchor points. If you have more anchor points, you can describe more colors. But then it gets more complicated. So 3 is not too complicated mathematically. It encompasses the most number of colors, and that's why screens are RGB. It encompasses the most colors with those anchor points. But the goal is not to say, oh, it's 10 red and 50 green and 5 blue. The goal is going back actually to the color order system. The goal is the lightness, the brightness, the chroma, the saturation. And that's what all this is supposed to be about. But getting everyone to agree on what the anchor points are supposed to be and what color order system and what encoding system to use is where the real difficulty is. And then from a manufacturing perspective, we can say mathematically, so I told you the Munsell system is based on 5 colors, red, yellow, green, blue, and purple. But what if you told me, Tucker, I don't want to do it in 5 colors. I'm only going to do 4 colors for my process. Okay, so now what do we do? You can tell me, oh, I'm going to do Rec.709. I'm going to send images in Rec.709 or Rec.2020. But LED screens cannot make Rec.2020. None of them can. Despite what you've been told, none of them can make Rec 2020. So, okay, what do you do? What are we supposed to do then? And the decisions that we make about doing that often can differ between companies. So that's when you hear about what people at ACES are doing. By the way, ACES just got promoted to Academy Software Foundation, a big update there. Congratulations, ACES team. You have ACES and you have Open Color IO. These are all tools so that enable us to communicate to each other. When I say red, green, blue, this is what that is supposed to mean in terms of a color.
Right. So sort of standardization kind of thing.
It's all the standardization.
Yeah.
What causes the problems? So then that's how the screen gets its color. That's basic. Really, that's how screens work. Okay. Yeah, there's a lot of details and bits, but that's how screens work. Then you put a camera in front of it. And you'd think, okay, the screen's RGB. We know the camera's RGB, should look perfect. But the reason it doesn't is that the camera is not sensitive like a human eye is. Camera companies are not paid to make human eye sensors. If they did, they would be very, very, very low dynamic range, actually. They're paid to make high dynamic range, wide amounts of tone, good color fidelity, low noise. None of those are things that happen in the human eye. Cameras are not meant to be the human eye, but screens and all the standards for calibration, like Rec.7 D6, D5, all these things are based on standards for the human eye. So you're looking at something that is meant mathematically and calibration-wise to be viewed by a human eye, and you're looking at it with something that is really, really, really far from a human eye. I was waving to him.
That's right. It's Josh.
It's funny. The cameras are not meant to be the human eye in any way. And so they don't see the LED wall the same way. And that is what really causes the difficulties for people when it comes to VP. On that front.
But I guess, sorry, just to quickly, I guess the other thing is that they weren't, and maybe you're going to tell me they are now, but they certainly weren't designed really to have a digital film camera pointing at them either, right? They in my head, they were designed for live experiences and people to look at them in shops and all these kinds of things. So they were sort of designed for the human eye, but suddenly this camera's going in front of them, right?
Yeah, originally that's definitely true. Actually, BP2V2 was designed for film studios. It was specifically designed for virtual production.
So what was that thing you just said?
BP2V2, Black Pearl 2.8 version 2. It's a very, very common LED tile for virtual production. And it actually was designed for virtual production. So
cool, okay.
Black Pearl 1 was a product designed for the rental and touring market, like you say, live events and that sort of thing. Some people tried to use it for some small movies, a Star Wars movie, Murder on the Orient Express, First Man, and it worked pretty well. The resolution was good enough, color was good enough. But there was a few issues. The refresh rate is not good enough. The bit depth could be better. They wanted an improvement. So BP2V2 actually, it was from the perspective of trying to do everything we could to make a product for that market. That is what the goal of that product design was. Actually, it still turns out that an RGB screen is a good choice. I won't say perfect choice, but it is a good choice for cameras because they are RGB sensors. So the same way that you have in old visual effects, you have a film slide, and you had a laser printer, and it shot a laser at the film slide to create optical density and print film with visual effects, or even to do film replication is the same process, right? So if you think about a digital sensor being a film slide, our LED wall is the same as the laser projector that's trying to print on it. So we're using an LED wall. We're shining red, green, blue light to print density or electron volts on the red, green, blue sensor of the camera. So even though the coupling's not perfect, it's pretty good. And the fact that it's not perfect, you can improve by calibration. You can calibrate the printer the same way that if you were calibrating a VFX film printer, you would print some film, measure the optical density, and adjust the laser. You can take some images, measure the exposure, and adjust the printer. That's what we're doing in virtual production. And if you do that, because cameras are not human eyes, if you only think about this from the theoretical perspective, which is very sciencey of me, but
No, go
it's
for it.
a
No,
useful
I'm in
perspective.
it. I'm in
If
it.
you
Yeah,
only
absolutely.
think about it theoretically, an RGB device coupling to an RGB film slide as a printer is the perfect combination. That is the
Okay.
perfect combination. From a perspective of, we want to very accurately control the printing process, the printer being RGB, the LED tile being RGB, printing on the camera is the best way to accurately control the camera sensor, because the camera sensor is natively some kind of RGB. But, big but,
The big but.
despite the fact that an RGB device is the perfect printer if it gets calibrated correctly for the specific type of camera sensor, despite the fact that that is a great printer, we don't just want to look at LED screens. We like to look at actors. We like to build sets because it helps with immersion. We like to put things in the forefront. We like to have lighting, all this kind of stuff. It really gets in the way of my happy theoretical printer. So, and I say gets in the way, but right, that's actually what we're here to do. You know, that's the magic of virtual production. So in that scenario, the background stuff where you're printing on the camera sensor, where you're doing the in-camera composite, you do really still want an RGB, a calibrated RGB. But for everything else, for immersion and for the skin tones, it's not enough. You need to go full spectrum, because cameras are meant to image the world as if it's being lit by daylight. And your RGB printer, your magical RGB printer, cannot magically print daylight in terms of after being reflected off of skin tone. The skin tone, I will say, all you foreground people and the cinematographers that want to photograph stuff, all that stuff is interfering with my printer. And we cannot simulate those interactions. We have to get it right. The only way to fix that is to get it right. You have to actually print the right spectrum, and then that interference prints the right color. So that's why you have the advent of these kind of full spectrum products. So we have a product that utilizes red, green, blue, cyan, and amber in a 5mm pitch. So that adds in to your studio a much, much, much more full spectrum source of lighting, so that all of these interference things we can still capture and print them correctly.
Got you.
So that's my perspective. That's my approach.
Yeah. Well, yeah. I guess. I mean, I suppose the interesting thing is that the industry in itself is under a lot of pressure financially and directionally, right, as well. So I think I was reading something about how there are studios are going up a lot, and some of them are being repurposed to be a lot to work for indie filmmakers a lot more, so less big blockbusters, and they're being repurposed for that kind of scenario. And actually, they're and talking about quite a lot of volumes are still going up, but they're not as big as they were before. Do you see, I guess virtual production has been a thing definitely since the pandemic. It was a thing before the pandemic, but it wasn't as big a thing because it was sort of this engineering invention. If engineers were asked to invent filmmaking, EP would have been, and they did, and that's what that's what they invented. In the past 5 years, it's gone this typical hype, the hype psych of it getting everyone getting excited and lots of things, and it's going to be the future of filmmaking. Then it's sort of, it's a bit disappointing, and maybe you use it for this, that, and the other. From your perspective of color, is it something that a filmmaker could fully embrace, do you feel, or is it something that it's a really great tool when it's an option to be able to to use, and typically that's driving plates is a great example. We had David Smith on last week talking about doing driving plates, and it's just absolutely you really wouldn't want to film a driving plate any other way, because it gives you so much flexibility and all this kind of stuff. Whereas for sort of the bigger scale things, or not even bigger scale, it's Do you think it can get general acceptance as a technology?
I think it's possible to. I have a few different types of answers. I know we're a little bit short on time today, so One answer is I know that there are some film projects that are still unannounced, but have really embraced the volume as a character, even within the story itself. And so I think creatively there are possibilities, there are stories to be told that are right to be told utilizing that technology. Those stories are going to be discovered and they're going to be written.
Yeah.
So I'm excited by that. From another point of view, the idea that we can do so much without so much location travel if we get the plates right, it's so tempting, it's so inviting, and it's so potentially helpful that there's going to be continued investment in it. Now, I don't think that every film is going to, I don't think that if you want to tell a story about someone driving across the state of Texas and discovering themselves and adopting a dog, go to Texas.
Right. Yeah.
There's nothing better than to just go to Texas and do that. That's no problem. But there are a lot of films that are more complicated or have more complicated logistics or have otherworldly scenarios, or you need to reshoot and the set and the backlot for that particular project is no longer in existence. And now we need to reshoot something. So there's lots of other cases where it can be a cost-effective venture, and that's why you continue to see investment in it, because it is still a good tool for other things. The decrease in size, I mean, the way I always explain that is I like to think about how many budgets or how many movies every year get made that have a budget like 130, 150 million dollars. Not very many.
Not many.
Most movies don't have a budget of $150 million. Very few. Those are the movies that can utilize the largest stages with the biggest infrastructure, the most number of cameras, the largest staff, the most detailed calibration. There are not many projects like that. So they exist, and those studios will see work, but we don't need dozens of those studios in the world. And I think there was a race from a lot of investors to build big studios, because they thought they would attract projects like that, but there's just not that many projects like that. So there's much more smaller projects, and that's where a team that has a small wall, knows how to use it for certain shots to achieve a creative goal, can plan accordingly. They can be effective, really effective with an LED wall, and that's why you still see a lot of smaller studios built, because there's more smaller projects, and that's also not a bad thing. And the last thing on this topic that I think about is a lot of people think about how does AI affect virtual production? I was just in the chat. I went on quite a rant the other morning, explaining in the chat my thoughts on AI. Didn't mean for my rant to go on so long, but it boils down to, like, the best AI models are struggling to keep a cohesive shot going for maybe a few minutes, maybe. And the complexity of putting together 27 minutes or 90 minutes or 60 minutes or 110 minutes is absurd. To keep the same detail of location across multiple shots, everyone knows it's a challenge, but the challenge will take huge numbers of GPUs. It will take orders of magnitudes of improvements in efficiency. And assuming that works out and the billions and billions of dollars get spent to do that, those investors who spent billions of dollars on doing that are going to need to make money. And the money is not going to be made in feature film. Unfortunately, I have to say the money is going to be made on YouTube Shorts and TikTok and news and maybe some episodic stuff.
I heard this stat the other day. We're going to have to finish in a bit, but I heard this stat the other day that Disney make more money increasing the cost of their corn dog at all of their theme parks than the entire portfolio of their film makes. They operate on a 5% budget or something like that, and
so
there isn't money. There isn't money there.
But that doesn't mean that those tools aren't valuable. So I think those tools they can accelerate. What I see it as is they're going to accelerate VP workflows. That's my prediction. If you like, the most difficult thing in VP is shot planning and making sure you develop the assets where you need them and bake lighting and all these things you've heard about. Well, if you can use AI to help assist in your shot planning and your creative development, you can save tons of money on the pre-production costs. And that
is fundamentally a productivity tool. My gut feel, it's not a creative tool. There's going to be bits, right? But it's like faxes overtook telexes. It's like phone calls. It's like the internet. All of these things became productivity tools that just made us to be able to. And I use it daily talking to my Unreal GTP, and I just ask it a question about how to do something in Unreal, it tells me. Or if I do the same thing I use for the Ultimate, anything, I just ask it, kind of thing. Fuck it, we're going to have to wrap it up, I'm afraid.
Yeah.
But we could literally have talked for another hour, I think, and I'm sure we will do. What are you up to? And when am I going to see you soon? And what's Ro up to? Very briefly.
All right. What I'm up to, I'm traveling. I'm working on secret projects at ROE.
Right.
Sorry, still secret.
That's right. Still secret.
But I'm going to be at IBC, and I think we're going to see in the next couple of years some major changes in what technology is available in virtual production on LED walls. And we're also going to see a big change in what's available in screening and cinema environments. And I'm really excited about both of those. So those are two things that ROE is kind of planning on seeing some changes in the next little while. I'll be at IBC. Yeah, I wish I would have loved to talk longer. I'm sorry I had to reschedule. I know that's on me, but
it happens.
Hopefully we get a chance to continue this.
We will. We'll do a part 2. As I say that to most of my guests, because we always run out of time, even after like an hour and a half.
Great.
So we'll do part 2s as well at some point anyway.
Great.
But Tucker, it's been an absolute pleasure. Safe travels. You're going back to the US soon, and then you're over in Europe, so you'll be in the air yet again, I'm sure, which you probably spend a lot of time in there. Absolute pleasure. And I'll see you soon.
Yeah, thank you very much, Rob.
All right, dude. Catch you soon. All right, hit the stop.